prove my point on what I ended the video with. On the last one, we talked about changing the radius of something. And so I said, so for the ice skater, something, when you go arms out versus arms in. So let's just say we go inertia equals mr squared. How about that? Because I can take this, I can have 1/2 mr squared, I can have any shape here. And when I'm doing something, just changing the radius of something, then I'm going to have, let's see, L initial equals L final, or I1 omega 1 equals I2 omega 2. This is just one thing, right? So I can put in any number of fancy things. In fact, let's try it with both 1/2 mr squared, so a disk, and a point mass. So for mr squared, let's say I have mass radius squared times omega 1 equals mass radius squared times omega 2. So what part aren't I changing? Well, this thing that always changes with our inertia, stays constant with our inertia, is this 1/2 mr squared. If we're talking about something alone, so just changing the radius of something, then its mass and whatever the coefficient that goes with for its inertia is the exact same. So I look over here, masses cancel, don't need it. So let's see, I have then radius 1, I need to be careful here. So I have radius 1 squared omega 1 divided by radius 2 squared. And that will give me my omega final. I'll be consistent, omega 2. So I have, let's see, my radius 1 is 1 meter times omega 1 is this 4 pi radians per second. An interesting noise outside. Divided by this 0.5 meters squared. And that will give me my omega 2. So let's put that into our calculators and see what we get. So 4 times pi. I should write that that's squared even though it's 1. Still squared. Divided by 0.5 squared is, wow, moving. So omega 2 is 50.2 radians per second. So by having the radius, the center of mass, the amount I'm stretched out, let's see, this would be like 12, 4 times 3, essentially 12. I have 5 times it. 5 times it, that's a legit word, I think. Okay, moving on to the next.